For homework tonight, please complete page 14 and correct it with this zaption. This is your last zaption of 7th grade. Today in class, we talked about a method called capture, tag, and recapture. So this first problem is talking about one of those situations. Youngnan wants to estimate the number of beans in a jar. So that jar is representing our population. So kind of picture a jar full of beans. This is our population inside. We have no idea how many there are. She takes out 150 and marks each one with a red dot. So she pulls out 150 and tags them and then adds them back into the population. So we're going to see some of them that are marked red amongst the whole population. Now she's going to take 4 samples from the jar. And now we're going to think about what is the relative frequency of total beans that are marked with dots. So for sample 1, there were 25 beans and 3 had dots. So what was the relative frequency of beans with red dots? 3 out of 25 equals what out of 100? While looking at the scale factor, I can see I can multiply by 4. For 25 times 4 makes 100. 3 times 4 would make 12. So this is 12% of the beans had red dots. For sample 2, 23 out of 150 had red dots. So again, I want to think about what part of that is out of 100. Another option for finding the percentage is you can divide 23 divided by 150, and you can look at that as a decimal and think about how many hundredths is that. So if I do that, I can see this is about 15 1/3%. I'm just going to say 15%. What about sample 3? Sample 3 is 15 out of 75. Again, if I want to think about what percentage that is, I can do 15 divided by 75, or I could look for a scale factor, and I get 20%. And finally, sample 4. 25 beans had red dots out of 250 total. I want to make that out of 100. So 25 out of 250 would give me 10%. So looking at my 4 samples, they range from 12%, 15%, 20%, to 10%. And now I'm going to think about how many beans could actually be in the population of the jar. Which sample has the greatest percent of marked beans? I brought my work in here from before, so this has 1, 2, 3, and 4. So looking at what I see here, the sample with the largest percent of marked beans would be sample 3. So now I'm going to use that sample to estimate how many beans are in the jar. And again, remember, I tagged 150 beans to start with. So thinking about what's there, in sample 3, I had 15 beans that were tagged out of 75 total. Now I'm going to expand that because I'm going to think about how well I got 15 of my tagged beans, but I actually put 150 in the whole population. So now I'm going to look for a scale factor to figure out how many beans are in the jar. So again, remember, this side of my proportion represents the sample. This side of the proportion represents the population. The top of the proportion is going to represent the number that were tagged or marked, and the bottom represents the total. So again, 15 were tagged out of the 75 I picked, and I know I originally tagged 150 of the beans. So now let's figure out what the population is. Let's find a scale factor. 15 times 10 would give me 150. 75 times 10 would give me 750. So that's my estimate, is that there are 750 beans in the jar. Which sample had the least percent of marked beans? The smallest percent of beans was number 4. I had 10% there. So now I'm going to estimate how many beans are in the jar. So again, I'm going to set up my proportion. So tagged over total. And again, the first part is going to be my sample. Next part will be my population. So I had, in sample 4, I had 25 that were tagged out of 250 in the sample. And I remember that I tagged 150 in the total population, and I want to figure out what the population could be. So again, I'm looking for a scale factor. So if I take 150 and divide by 25, I would get 6. So 25 times 6 is 150. 250 times 6 would give me my new population, which is 1,500. So again, if you think about it, if I think that the higher frequency of 20% is more accurate, then that might lead me to think that I don't have as many in my population. If I think the lower frequency is more accurate, then that would suggest to me that my population is bigger, right? Because when I drew my sample of 250, I only got 25, which is just 10% of the total, versus when I drew 75, I got 15, which was 15% of the total. So now let's move on to the next model. Daya used the shaded bars below to make an estimate from sample 3. Explain what the bars show and how they can be used to estimate the number of beans in the whole jar. So looking at sample 3, I see that the number of samples of beans in the sample is 75. And I see that 15 or 25% of them, 20% of them are marked. So I can see that there were 5 sections here, right, representing 100%, and I've shaded in 20%. Then over here, I see the whole jar. It says number of beans in the jar, and I wrote 150. It says or 20% marked. So I'm trying to find this piece here. I don't know how many are in the jar. However, if I'm looking at the sample, 20% of the sample was marked. So if I recognize that 150 is 20% of something, I can build up what my total population could be. Because if I look at this, 75 is made up of 15 plus 15 plus 15 plus 15 plus 15, right? That makes that total of 75. So down here, I'm going to add 150 plus 150 plus 150 plus 150 plus 150. So when I add all those 150s together, I get a sample size, or a population size of 150 times 5, which will give me 750. Now we're going to use our answers to parts A through D and think about what is our best guess for the total number of beans in the jar. So take a moment and think about what would you explain as the best guess for the total number of beans in the jar, and be prepared to explain your answer tomorrow.